Okay, so in this video we're going to talk about the derivative of e to the f of x. So in this case, instead of just having e to the x, which we learned the derivative of e to the x is e to the x, now we're going to have in the exponent a function of x. So here we're going to use this rule that d dx of e raised to some function of x is the derivative of the exponent, so f prime of x, times the original function e to the f of x. So for example, let's say we were looking for d dx of e to the 5x. Then what I would do is I would look at 5x as being my f of x. And we know that the derivative of 5x is just going to be 5, so that's f prime of x. And that's going to be times the original function e to the 5x. Or if we have something like d dx of e to the x squared minus 4x, then again what I'm going to do is I'm going to put the derivative of the exponent first, so that's 2x minus 4, times e to the x squared minus 4x, which is the original function. So this turns out to be useful again for when we're starting to do things like the power rule and combining the power rule with the derivatives of the exponential function. And we'll see that there are applications of this when we get to things like compound interest and a few other things like principal value. So let's look at one more example. And let's say, for example, we have d dx of e to the square root of x squared minus 3. Then what I could do is say that this is d dx of e to the x squared minus 3 to the 1/2. All right, so now in this case, this here is my f of x, so I have to figure out what the derivative of that is. And to do that, we'll use the extended power rule. So I have 1/2 x squared minus 3 to the minus 1/2, and that's times 2x. Okay, and then I'm going to write that times my original function, which is e to the square root of x squared minus 3. And I can simplify this 2 and this 2, and I can move this x squared minus 3 to the denominator. So this ends up giving me x times e to the square root of x squared minus 3, and that's all over the square root of x squared minus 3. Since I have x squared minus 3 to the minus 1/2, that's the same as putting x squared minus 3 to the 1/2 in the denominator, which is the same thing as the square root of x squared minus 3. So with these rules, we'll be able to solve for a whole bunch of different examples using things like the product rule and combining this with the power rule. So let's say, for example, we have something like this. G of x is equal to e to the 3x over x to the 6th, and we want to find g prime of x. Okay, so one way I might write this is g of x equals x to the minus 6 times e to the 3x, and here I'm going to call this first term f and this second term g. And I'll say that this is a first function, which is x to the minus 6, times the derivative of the second function, so that's 3e to the 3x. So I take the derivative of the exponent, which is 3, and multiply that by the original function. And that's plus the second function, which is e to the 3x, times the derivative of the first function, which is minus 6x to the minus 7. Okay? And this would be a reasonable answer. We could also simplify this a little bit more and say that this is 3e to the 3x over x to the 6th minus 6e to the 3x over x to the 7. I just pull this minus sign out in front. I have my e to the 3x. I pull the 6 out in front. And this x to the minus 7 I turned into an x to the 7th in the denominator. Okay? So you'll see one other kind of example that appears on your quizzes and that may appear on your tests, and that looks something like this. Let's say that we want to find dy dx for y is equal to the square root of e to the x plus 1. Okay? So again, what I'm going to do is I'm going to rewrite this as a power rule, so a power function. So I'm going to say y is equal to e to the x plus 1 to the 1/2. Okay, and then I'm going to use the extended power rule on this. So this here, e to the x plus 1, is my inner function. So if I say dy dx, that's equal to 1/2 times e to the x plus 1 to the minus 1/2. So that's applying the power rule to the outer function. And then remember, we have to multiply this by the derivative of the inner function. And if we have e to the x plus 1 as our inner function, then the derivative of that is going to be just e to the x. So I could rewrite this as e to the x over 2 times the square root of e to the x plus 1. I just move this 2 into the denominator, and then e to the x plus 1 to the minus 1/2. I move an e to the x plus 1 to the denominator, and to the 1/2 to the denominator, which is the same as the square root of e to the x plus 1. So these kinds of examples are the ones that are going to appear on your My Math Lab, and you'll also see some questions like this on the test, combining the different rules that we've learned, the power rule, the extended power rule, and the new rules that we have for the derivative of e to the x and the derivative of e to the f of x.